Just a couple of reminders. Phones, smartwatches will hinder your grades. Sneakiness, like get on your phone and expecting I don't see you, that is going to hinder your grades. Nonsense will hinder your grades. Disruptions will hinder your grades. So just basically just let me do my job. While no disruption, you'll be alright. Tutors are Tuesday, Thursday, 5 p.m. to 5:30 online. If you can't make that, try to come to any of my classes, provide permission from your teachers. My prep period, 8A, second block, B-Day, fourth block. So you got 3 opportunities to get tutoring. I'm not doing no more special tutors for no one. I'm not doing no tutoring at 6, 7 o'clock. That's not going to happen because I gave you every opportunity to do whatever. You yourself have to make the sacrifice to get your education. You're going to make that sacrifice, not I. I already got my education. So you got to get yours. As stated, we are going to be dealing with the unit circle some more. However, this definition is very, 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 very critical. The precise definition of mathematics is the technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. This is something that I am going to quiz and test you on a lot. So you have to know this definition. I'm going to do the best I can to make it out multiple choice. I'm going to try to do that. I'm going to try. I said I was going to do it, but I'll do the best I can. Alright. So far, we've been working with a 30-degree triangle, 45 and 60-degree triangles. We made some observations noticing that we come to the 30-degree triangle. The long leg is going to be here on the x-axis, and it's going to be wherever the length is of the short leg times square root of 3, and we know that the hypotenuse is on the y-axis, and that's going to be the short leg is going to be on the y-axis, and we know that the hypotenuse is r, and it's going to be twice the short leg. So wherever that short leg is, that's where we're going to make it. But when we come to the 45-degree triangle, we know that the short and the long leg have the same exact measure, but the hypotenuse is going to be the same length of both legs times the square root of 2. For the 60-degree triangle, we know that the x-axis is going to have the short leg, so it's just going to be x, and the long leg is going to be x square root 3. It's going to be the new long leg, and the hypotenuse is going to be the same as that 30-degree triangle, which is just 2 times x. So we know these things. And we also know the unit circle. Alright, circles and Pythagorean theorem. We do not need to know about radicals because you already have did those things about radicals. And we know a circle is what? is to set all points on a plane that are the fixed distance from the center. And that's another eloquent way of putting it, but that's the most simplistic way. So you should know this, and of course I'll quiz you on that. If we know that this is the equation of the center, the xy is the measurements between the measurements from the center of the circle, and HK is my center points, and R is the radius. So we know all those pieces. They're going to derive something very, very, very important, which is the Pythagorean theorem. So we have proved the Pythagorean theorem, which you must know how to prove the Pythagorean theorem from the circle. That's for you to know. I already told you how to do it. Use follow it and just go from there. I need for you to have this line, everything included from here. Fun facts. A spin-off of the Pythagorean theorem. As I told you guys before, the Pythagorean theorem is going to have lots of pieces involved. So, it's going to have a squared plus b squared is c squared. That's your middle school version of it. I have taught you, for dealing with the unit circle, that x being your adjacent leg, y is your opposite leg, and r is your hypotenuse. That's the new Pythagorean theorem. And we also know is that the new version of this is cosine plus sine equals 1. So we know that. And we know that x comma y, the point is now cosine and sine, which is the same as a and b. So we know those things. And this is what we know before. No need to go over it. Take a moment and try to figure this out on your own. Pause the video. Once you figure this out, then do it. Then compare your answers to my answers. Pause the video right now. Alright, if you pause the video, good for you. So here's the answers I got. If you got those answers, hoorah, good job for you. And again, we try and work on the unit circle some more. So the only thing we did is just did the degrees and we found the trig ratios. So these triangles, the red one represents the third degrees, which we know that on the x-axis is going to be the longest leg. The 45, they're going the long and the short and long leg going to have the same measure. And then if we do 60, the short leg is going to be the x, and the longest leg is going to be the y-axis. Okay, let's find these trig ratios. So I gave you cosine of 30 degrees being 1/2, opposite over the adjacent. Cosine, and then there go tangent. Did those a little quick there. If you're trying to figure out how I come up with that, just use your trig ratios to figure that out. We talked about this at length, so I'm not going to talk much about it. Conversions. So let's convert these. So if I went from 30 degrees and I'm trying to find the radians of it, we go from degrees to radians. You're going to have to divided by 180. That's how you convert from degrees to radians. So 30 divided by 180 is going to be 1/6 or pi over 6. Make sure you always include the pi at the final part of your answer. Now, if I'm trying to go for radians to degrees, I'm going to have to multiply by 180. So 180 times pi is 180 pi divided by 4. And it also has pi attached to it. Part of the formula. Please look at your formula sheet if you do not have that down. We went over this before, so just do it. And we go 180 divided by 4, you get 45 degrees. 60 degrees, 60 divided by 180 is not going to give you power 6, it should give you power 3. Just like that. It's time for us to do our rotations. So this again, is when I give you the instruction. You doing it with me before I let you go do everything else. So we are doing reference angles. Last class period we filled out the unit circle in terms of degrees, but we didn't figure out the reference angles of each one. And to do that, like for example, if I was going to say 120 degrees, now I'm trying to find the reference angle that, well, I know 120 degrees, it's not quadrant 1, it's in quadrant 2. And because it's in quadrant 2, I gotta get 180 and subtract it from 120. So 180 minus 120, that's gonna be 60 degrees. So that means that my reference angle 120 is 60 degrees. Alright? So what if I had 220 degrees? Well, I know 220 degrees is in quadrant 3. So 220 minus 180, my reference angle is 40 degrees. If I was at 320, I gotta go from, because it's in quadrant 4, 360 minus 320, and that's gonna give me 40 degrees. Alright? So let me rewrite this so you guys could see this better. So I said 320 because it's in quadrant 4. Well, 360 minus 320, and that's 40 degrees. So that's how I figured this out. And 40 degrees is my reference angle. Alright, so let's try some, shall we? Again, we just trying to find reference angles of all of this. All right, so I'm not gonna do all of these because it's very, very, very easy. I'm gonna do a couple of them, and then you're gonna do the rest on your own. So we did 120 already in the previous slide. So let's do 150. Because 150 I know is in quadrant 2, I go 180 because that's the highest degrees I can go. 180 minus 150. And if I subtract the reference angle, it's going to be 30 degrees. Again, I know that it's in quadrant 2 because in quadrant 2, the highest degrees I can go is 180. So the angle had to be between 91 degrees and 180 degrees. Alright, so let's do 210. 210. I know that is in quadrant 3. So what I like to do, because of that, I go 210, and because it's bigger in quadrant 2, I subtract 180. So 210 minus 180, that's just 30 degrees. Sorry, y'all. Allergies. Alright, let's do 240. So 240, it is in quadrant 3, meaning that it's bigger than 180. So 240 minus 180. So 240 minus 180, that's 60 degrees. Alright, so I did some in quadrant 3, so let's do stuff in quadrant 4. Let's do 300, because 300 is in quadrant 4, meaning that it's from 271 to 300 to 360 degrees. So you're going to go 360 minus 300. And when I subtract that, that's 60 degrees right there. And you will notice something through these, that these angles are going to repeat from each other. So sometimes you're going to see 60, 30, 45 a lot. You're going to see those symmetrical numbers. So if you are still confused on how to figure the reference angle, go back to the previous part where I had the graph and I was telling you the quadrants and how to subtract. So look at that before you continue on with this video. Alright, why don't you try and convert 5 pi over 4 into degrees to find the reference angles? So, before you even have to convert, you shouldn't have to really convert to find out that reference angle. The reason why you shouldn't have to worry about convert because of our magical radians that we know of. We know pi over 6, that's going to be 30 degrees. And we know pi over 4 is our 45 degrees. Anything with the denominator of 4 is always going to be 45. So therefore our answer is 45 degrees. Because all you have to do is look at the denominator and see, does it fit one of our magical radians, like pi over 6, which is 30, pi over 4 being 45, and pi over 6, well, pi over 3, my bad, is 60 degrees. So if I got 30 degrees here, well, why is that pi over 45? Because pi over 4 is 45 degrees, that's why. I'm sorry about that, y'all. And then pi over 3 is 60 degrees. Put the circles there. It's hard doing this on a mouse than actually writing this out. I miss my stylus. But yeah, so anytime you see a radians, always check your denominator. If it's pi over 6 somewhere, it doesn't matter about the numerator. Guess what? It's 30 degrees. So you see something over 4, it's 45. If anything over 3 is 60 degrees. Alright, so let's go through this. So we know 30, 45 is 60. And we know that 150 is a reference of 30. 135 is the reference of 45. And 120 is a reference of 60. Alright? We know that 210 is a reference of 30. 225 is a reference of 45 degrees. And 240 is a reference of 60. We know that 330 is a reference of 30 degrees. We know that 315 is 45, and then 300 is 60 degrees. And these are the important references that we have to know about. A is going to be all together, and then T, whatever technology I gave what you can do, I'll be project 1, polynomials in U, or do Kahoot if you have already finished. But do not do Kahoot had you not did project 1. If it's not 2 full pages, do not submit that in to me. H is hands on. Alright, y'all, that's it.